Okay, so this is a tutorial on finding the area between two curves or two equations. We're not rotating anything right now, we're just finding area. So basically there are these two equations, formulas for finding the area. There are different scenarios where you should use HIDX and different scenarios where you should use WIDY, and I wrote those scenarios below each one. So let's take a look at HIDX. You use HIDX when the equation is y equals something about x. So for example, if the question said find the area between y equals x squared plus 3 and y equals 2x plus something, it's y equals and then there's an equation that includes x in it. That's when you use HI. And this is also when you use the vertical strip. When it's y equals something about x. In this scenario, you use the vertical strip. And in order to compute HI, you do y top minus y bottom. I'll explain what this means in a second. For WIDY, you basically use when the equations are x equals something about y. So if the problem said find the area between x equals y squared plus 3 and x equals 4y minus 7 or something like that, x equals something about y, and then here it's y something something, that's when you use WIDY. And in this scenario you use the horizontal strip. And here, in order to compute WI, you use x right minus x left, and then I'll explain what that means in a second. So there are about 5 steps for finding the area between two curves, or two equations, or whatever you wish to call it. So step 1, you have to find the boundaries. Now if the boundaries are already given in the question, you can skip this step. Step 2, you determine which strip to use, whether it's vertical or horizontal, which strip, and then you draw the strip. It really helps, it's very helpful. Step 3, you could find HI or WI depending on whether we're using vertical or horizontal strip. Step 4, you set up the integral, and then step 5, you solve the integral. Okay, so let's do an example problem. Find the area between y equals x squared plus 2 and y equals 2x plus 5. This is what the graph would look like, and we're finding the area between these two curves. We're finding this area. So step 1, let's find the boundaries. Because the boundaries are not given to us, we can find them. They're not given to us in the equation, so we'll find them. So in order to find the boundaries, you set equations equal to each other, and then you solve for x. These are the two equations. We're going to set them equal to each other in order to solve for x. So x squared plus 2 equals 2x plus 5, and then we're going to solve for x here. I just basically put these two equations, I put them equal to each other, and then now I'm going to solve for x. So here I basically solved for x. I'm pretty sure most of you know that this is just basic algebra. So these are the boundaries. X equals -1 and x equals 3. These are going to be the boundaries for the integral that we set up. Alright, so let's do step 2. So now we're going to determine which strip to use, whether it's vertical or horizontal, and we're going to draw the strip. So like I said, right, okay, so this is finding this. The question says find the area between y equals x squared plus 2 and y equals 2x plus 5. As you can see, it's y equals something about x. There's x in the equation, and then y equals something about x. There's x in the equation. Now if we go back to the original sheet, when it's y equals something about x, we use the vertical strip. See? Y equals something about x, y equals something about x. The equations are y equals something. So because of that, we're going to use the vertical strip. So let me draw that for you guys. Where's my blue marker? I'll just use this black marker. So I will draw a vertical strip. We'll just put xi here. Xi is the x coordinate of this vertical strip, and then dx is just the thickness, I guess. But yeah, basically, that's just important to just put there. But basically, the strip is vertical because it's y equals something about x. So that's how we determined that it was the vertical strip that we should use. Okay, step 3 is find HI. Like we said over here, we're finding HI because it's a vertical strip and the equation is y equals something about x. That's why we're using HI. So basically, we have to find HI, and the equation for HI is y top minus y bottom. So let me explain what y top minus y bottom means. HI, basically, I can draw HI here. HI is the height of this strip. Now, in order to find the HI, it's y top minus y bottom. Y top is the equation that touches the top of the strip, which is this. Y bottom is the equation that touches the bottom of the strip, which is this. So, if I were to find HI, let me write that out. So to find HI, we're doing y top minus y bottom, and as you can see, y top, the equation that touches the top of the strip, is 2x plus 5. So y top is 2x plus 5. Y bottom, which is the equation that touches the bottom of the strip, right here, that's in green. Oops, let me not scatter the paper. Which is green, that's this equation, x squared plus 2 minus x squared plus 2. This, let me close parentheses. This is y top, touches the top of the strip. This is y bottom, touches the bottom of the strip. So this is what HI equals. So we've established that this is what HI equals. HI equals 2x plus 5 minus x squared plus 2. So if you subtract these two equations, if you do 2x plus 5 minus x squared plus 2, if you subtract these two equations, you get negative x squared plus 2x plus 3. This format is going to make it a lot easier to integrate. So basically, this is what HI equals. This, before anybody goes, oh, how'd you get this from that? This is literally just me subtracting these two equations, and I just did that to get this, okay? So that's HI. HI is basically y top minus y bottom. I subtracted it in order to get this, and then I got this. Alright, so now let's do step 4. Let's set up the integral. So remember, this is the equation or the formula we're using for this one. This is going to help us set up the integral. So the boundaries, and then HI dx. So we already determined that the boundaries, like remember from step 1, we said the boundaries were x is negative 1 and x is 3. So I'm going to put negative 1 and 3 here because those are the boundaries. And then HI dx is, let me rewrite that, negative 1, 3. From the step we just did, which is step 3, we already found HI, which was this minus this, which when you subtract it, it really equals this. But let me write it twice just so you guys can understand it. It's 2x plus 5 minus x squared plus 2. We put some brackets, dx. Do not forget dx. Dx, right? But when you subtract these two, what you really get is don't forget dx. So that's what you get when you subtract these two. Remember when I subtracted these two? That's what you get. This is HI and then that's dx. So we've set up our integral. Now we're ready to integrate. Oh, and if in the question it says set up the integral but do not integrate it, set up the integral but do not compute the integral or do not evaluate the integral, then you can stop at step 4 if the question says that. If the question just says to set up the integral and that you don't have to evaluate it, you can stop here. But if the question says set up the integral and evaluate it, then we'll do step 5. And now we can go on to step 5. Alright, step 5, now we can solve the integral. Basically this is easy. This is just Calc 1 stuff. You're just gonna basically solve this integral. So this integral would equal negative x 3 over 3 plus 2x squared over 2 plus 3x at 3 and negative 1. That's basically what this integral equals. When you do the math and the computation, it's gonna look like this. Let me write it in red. It's gonna look like oh, and by the way, you can take the 2 out and just have this be x squared, but I just kept it there. It doesn't matter. It'll come out to the same thing. If you want to simplify it, you can. And then that comes out to being 9 minus negative 5 over 3. 9 minus negative 5 over 3, which is 27 over 3, because that's 9. Then I just put this into fraction to make it to, so we can add it. Minus minus is plus. Plus 5 over 3, which equals 32 over 3. This is the final answer. That's the final answer, 32 over 3. Okay, let's do another example. In this example, we're going to find the area between x equals y squared and x equals 2 minus y squared. So let's start step 1. Let's find the boundaries. So to find the boundaries, let's set this equal to each other. Let's put 2 minus y squared equals y squared. Let's put this equation and this equation, and let's set it equal to each other, and then let's find y. I'm gonna put 2 minus y squared equals y. Ooh. Y squared. Does that look like a y? Sorry. So 2 minus y squared equals y squared. It's this equation and it's this equation, and I put them together. Now, let's solve for y. So, okay, so yeah, I just decided to just solve for y. Yeah, I just did some basic algebra to solve for y. So the boundaries are y equals negative 1 and y equals 1. These are going to be the boundaries for the integration. Okay, so here's step 2. We have to determine which strip to use and draw the strip. So if you refer back to the original paper that I used, as you can see in this equation, in this problem, it's x equals y squared and x equals 2 minus y squared. As you can see, these two equations is x equals something about y. Here it's x equals something about y. Here it's x equals, and here it's an equation that includes y, and then here it's x equals, and here it's an equation that includes y. So if we go back to the chart that I had, we can use wi, and then we can use a horizontal strip, because for wi we use when the equations are x equals something about y. Here x equals something about y, here x equals something about y. So because of that, we're going to use the horizontal strip. Let me write that. Let me draw that. I'll draw it in blue. No, that looks too much like green. Okay. I'll draw a horizontal strip here. I'll just draw it and I'll color it in. So yeah, this is the horizontal strip that we're going to use. The y component, like the y value of this strip is yi, and then this right here is dy. I'll just write that. And then, by the way, the width of this strip is wi. Alright, so let's do step 3. Basically, we can just find wi. So as I said in earlier, wi is the width of this strip. Like the width of this strip, basically. So in order to find that, we're going to subtract x right, and we're going to do x right minus x left. X right is what touches the strip on the right side of the strip. That's what x right is. As you can see, what touches it on the right side of the strip is x equals 2 minus y squared. X left is the equation that touches the left side of the strip. As you can see, the equation that touches it on the left side is x equals y squared. So in this situation, x right is 2 minus y squared, and x left is y squared. I hope you guys can see that. Okay, so yeah, wi is x right minus x left. So like we said, x right, the equation that touches the strip on its right side, is 2 minus y squared. So x right is 2 minus y squared. X left is the equation that touches the strip on the left side, which is y squared. So I put y squared here. So I did x right minus x left. That's 2 minus y squared minus y squared. This is wi. This is what wi equals. So then I just did 2 minus y squared minus y squared. I did it here in order to get 2 minus 2y squared. This format's going to make it easy to integrate. But the reason why I subtracted is because I see it here. And so like 2 minus y squared minus y squared, basically just 2 minus 2y squared. And so then this is what wi equals, 2 minus 2y squared. Basically, I just subtracted this and this to get this. That's all I did. Alright, now it's time for step 4. It's time for us to set up our integral. Since we already established, that we're using the horizontal strip, and that means we're going to use this equation, integral of wi dy, so that's why I put that here. From the boundary step, which is step 1, we already established that our boundaries are -1 and 1. Let me write it like this so nobody gets confused. And then from the previous step we just did, step 3, from the step we just did, we established that, I'll write it twice so nobody gets confused. Wi is 2 minus y squared minus y squared. Let me put parentheses, let me put some brackets. Dy, because this is wi, okay? This is wi right here. And then, when we simplified it to make it easier to integrate, we got 2 minus 2y squared dy. Do you guys see, like how, yeah, so then this is how we set up the integral, and now it's ready to integrate, so step 4 is finished. And by the way, like I said in the other, when we did in the other problem, if the problem says to just set up the integral and do not evaluate the integral or do not compute the integral, you can stop here. But if it says to evaluate the integral, then you evaluate it, and then we can go on to step 5. Alright, so here's the final step, step 5. Basically, we solved the integral from Calc 1. I'm sure you guys can do this. It's the integral from -1 to +1 of 2 minus 2y squared dy. Do not forget the dy. Basically, this would equal 2y minus 2y cubed over 3 at 1 and -1. And then we can just do like algebra to like solve this. So just plug it in and solve it. So yeah, I just went ahead and did the computation for it. Basically, you plug, you guys know from Calc 1, I don't even have to repeat it. So basically, you solve it, and then you get 4 over 3 minus negative 4 over 3, which is really 4 over 3 plus 4 over 3. Final answer is 8 over 3.